Hey everybody, let's give this problem a try. So there's a highway, let's say with a curve like this, and then let's say it's a circular curve, so there's a radius right here, right? So we know this radius, r, and then if let's say there's a car going like this, driving around this curve, so what does the velocity of the car look like? It's going to this way, and then this way, and then this way. And let's assume that this is a constant speed. The speed meaning the magnitude. The direction is definitely changing, right? Because the car is turning. So the velocity is not constant, but let's assume that the speed is the magnitude of the velocity. Okay, so then what we have here is uniform circular motion, because we have radius and then a constant speed. So, and then here it's saying that it's banked. So in other words, like this is the top view. If we look more like from the front view, then the road looks kind of like this, like, kind of exaggerated, but like it's at an angle, and then the car is in this view like driving into the page. So what does the free body diagram look like? Like here's the car at that banked angle. So again, the road is like this. So then there's got to be a normal force like this, normal to the road, and then the car has weight. And we're looking for some kind of ideal angle, because what happens if you go too fast, like really fast? Then you're gonna just go straight off the road. Off the road means which way? This way. Right? If you go too fast, you can't make this turn, so you're going to go this way, which is this way. So you're going to start to veer up that bank, in which case friction opposes your motion in that side-to-side way, which would be this way. Right? So if you're going too fast, there's got to be friction this way to keep you from going off the road. But let's say you go really slow, like you stop. Then it's just like having a mass sitting on a ramp, in which case the car will want to slide down the ramp, which means there's got to be friction opposing that motion this way, this way. So again, if you're going really fast, friction has to act this way to keep you from going off the road. If you're going too slow, friction has to be this way to keep you from sliding down the bank to the inside of that road. But if everything is ideal, you're going at just the right speed where you don't need friction this way or this way. So you have the right speed and the right angle and the right radius. Then we have this ideal situation like this. Okay. Which way is the car accelerating? If the magnitude of the velocity is the same, there's no acceleration into the page here. But then the direction of the velocity is changing, so there's definitely acceleration. And that acceleration is centripetal. Right? Like if this is the center of the circle, then the acceleration is pointing toward the center of the circle, which means centripetal. Right, so the acceleration is centripetal. Which way is that? Look at this picture right here. Toward the center of the circle is this way. From the top view, what about this front view? This way, right? Because this center of the circle is like this. So centripetal is this way, which is this way. This way is centripetal. that's toward the center of the circle. So I'll make that one of my coordinate axes. Then I'll make another axis. And here's our free body diagram with our coordinates. Okay, and then if we have an angle, let's say like this, then that angle's got to be here. And now let's write Newton's laws. So in the x direction, we got this. In the y direction. All right. And then again, the only acceleration is centripetal this way. There's no acceleration this way. So AY is 0 and AX is centripetal. So I'll just write it here. AX is V squared over R, centripetal. Okay, so then we're trying to solve for the angle. Okay, so let's substitute, well, here we have some unknowns, so we can substitute n cosine theta minus mg equals 0, so therefore n equals mg over cosine theta. And then we can take that and put it here. So let me do that. I'm writing this equation. N sine theta equals mv squared over r. And if we want to solve for the angle, let's simplify this a little bit more. Mass is non-zero. I can divide both sides. Sine over cosine is like tangent. Okay, I can put the g over here. And then just arctangent. So then the angle is arctangent of v squared over gr. Okay, and then we were given the speed. Just make sure to convert everything to SI units. So the 105 kilometers per hour, or just convert that to meters per second. And then this kilometers convert to meters, right? So 1200 meters, and then 105 kilometers per hour. And then there are 1000 meters in a kilometer, and there are 3600 seconds in an hour. So then if you look at this, kilometers, hours, then this will be meters per second. Okay, so give this a try. Hopefully that was helpful. And let me know if you have more questions, and I'll see you in the next video.